Okay, now we're going to use rational equations to satisfy certain conditions, which basically utilizes the idea of substitution. If you know how to substitute, then you can do these very easily because we already know how to solve our rational equations. So it's just a matter of substituting things in and then going from there with the processes that we already know how to use. So let's say, for example, I want to find all values of x satisfying the given conditions. And let's say that my first condition is that my y1, which simply means the first y, don't let that subscript fool you, it just means the first y. It's going to equal 7 times 3x minus 2. That's in a parentheses plus a 5. And let's say that my second y, again, don't let the subscript fool you, y sub 2 simply means second y. That's going to equal 6 times 2x minus 1 plus 24. And let's say that I want to set it up so that y1 equals y2. That's the condition that needs to be satisfied. Well, that's very simple. All that means is now this is y1, this is y2. This says they're equal to each other, so you just set them equal to each other. Now that they've been set equal to each other, I simply solve the equation. And we know that to solve this equation, we have to distribute. Remember, only distribute up to the parentheses. Don't distribute beyond the parentheses. Distribute here. Combine up the like terms. Combine up the like terms. And now what we're going to do is we're going to add a 9 to both sides. And then subtract the 12. Now in the past I've always gotten all my variables on one side first and all the constants on the other side second, but it really doesn't make a difference because the goal is just simply get all your variables on one side, constants on the other. Makes no difference the order that you do it. Notice here we didn't worry about an extraneous root because you only worry about an extraneous root whenever you have fractions in your equation. I didn't have any fractions to begin with. So there was nothing that was going to create a 0 in the denominator. I had nothing to worry about there. The answer simply is x equals 3. Now let's try one more. Let's say this time my y sub 1, remember don't let that mess you up, that just simply means the first y is going to equal x plus 1 over 4. And let's say that the second y is going to be x minus 2 over 3. And let's say that the condition we want to satisfy is that y sub 1 minus y sub 2 is going to equal negative 4. Well, now remember what that means is I'm taking this and I'm subtracting this. And when I do that subtraction, I need to come up with a negative 4. So I'm going to take my first term, subtract my second term, and that's going to equal a negative 4. Well, that looks an awful lot like the rational equations that we've just been solving. And we know that since we hate these fractions, we want to get rid of them. And the way you get rid of them is you multiply every single thing by that LCD. Well, when I look at the 4 and the 3 in the denominators, the least common denominator for that is going to be a 12. So I'm going to take every single term and multiply it by that 12. Every single term multiplied by that 12. There go my pens again. Every single term, even the back, by that 12. So what happens is that now 4 goes into 4 once, 4 goes into 12 3 times, and all I really have here is a 3 times an x plus 1. Here 3 goes into 3 once, it goes into 12 4 times, and all I really have is a negative 4 times an x minus 2. Now yes, the 4 is on this side, but multiplication is commutative, so I can switch the order of this multiplication, and notice that I'm subtracting whatever is being multiplied here. And then on this side, a 4 times a negative 12. Well, I know that that 4 times a negative 12 is really a negative 48. And here I know that all I have to do is distribute through 3x plus 3, distribute through negative 4x plus 8. Very simple equation to solve. Collect up all those like terms. 3x minus 4x is a negative x. 3 plus 8 is 11. And now to solve that, simply subtract the 11. Negative x equals a negative 59. Divide by that negative 1. X is going to be a positive 59 here. Once again, be careful about the extraneous roots, but these denominators, yeah, they are denominators, but they're numbers. There's no variables in the denominator, so we don't have to worry about what's going to create a 0 in the denominator. There's not going to be a 0 in the denominator. This is it right here. And you know that that's done.